daily Leetcode challenge problem is maximal rectangle. So here we are given 2D array which contains zeros and ones. We have to find the largest rectangle containing only ones and return its area. So in this example, what could be the possible answers? This, that is 4 into 1, which will be 4, and this alone can also be the 1, or this, that is 3 into 2, which is 6, and it's the maximum, so we will return 6. Okay. So hope you have understood the question. Now what will be our approach for solving this particular problem? See, what we will do is it's a stack problem. Okay, so what I say, a monolithic stack. So what does this mean? The stack which is either containing in increasing order or decreasing order. So first I will take you to another problem which is a part of this problem only. Okay, so this is a histogram problem. I'm not sure you have solved this, but I will explain this also. So basically, we will be solving two problems at the same time. So this the same function I will be calling to this particular problem only for solving the this question, right? So first let me explain how this code is working. See, here also the same way. What we have to find the area of the largest rectangle, but here we are given a array instead of a 2D matrix. Okay, so in the 2D matrix we will create a histogram, and then we will basically form a vector in this way, and we will call this function only to give the maximum area. Okay, that's why I'm explaining this problem first. So hope you have understood this problem. Okay, so in this example, we can see what will be the maximum area. So the maximum area is 5 into 2, which is 10. So this 2 is the width and the height would be 5. Okay. The other possibilities can be 6 into 1, right? Or 3, this 2 into 4, which is 8, but still it will be less than 10. The maximum is 10, so we are returning 10. Now, if I explain this, how it's going to work, this code. Okay. See. Here I have taken this another example which is 2 and 4, which is given here only. Okay, this one, second example. Okay, this is small, so it will be easy for dry run. So that's why I've taken this particular example. I'll explain the first one also. Okay, first let's go through the code because it will become easier then to understand the problem. So what is the problem state? We are given this height vector, which is this 2 and 4. Okay, what we have to return is maximum area. So maximum area would be either this 4 or 2 into 2, which is equivalent to 4 only. So the maximum area is 4, so we have to return 4. Okay, so what is the code is doing? So we have taken the stack, we have taken a max area variable. Okay, and what we are doing is we are traversing through this particular vector. Okay, so the initially, so see, here we are going till less than or equal to n. Why we are doing this, I'll let you know. But when we reach to n, we will simply take current height is equal to 0. Okay, otherwise we will take the original height, which is height of 0, height of I. So currently I is 0, so height would be heights of I, which is 2. Okay, so now we are in this loop, while loop. Okay, we have to check if we can enter into this loop or not. Stack is empty, so see, currently our stack is empty, so we will not enter into this condition. We will directly come here and we will push I. So I is 0, right? So 0, so stack is empty, so I have pushed 0 index into the stack, and at index 0 we are having 2 value. Okay, then I is equal to 1, current height would be I 1 is equal to 2, no, so current height would be 4. Okay, 4. So because at one index we are having 4 now, that's why. Now we have to check this condition. Stack is empty, no, stack is not empty, and height of st dot top, that is height of st dot top, height of st dot top will be 0. So at the 0th index value, so 2. So 2 is greater than current height, which is our 4. So if 2 is greater than 4, uh, again this condition do not satisfy, so we will simply push 1 into it, right? So we are creating a monolithic stack. That means we will be storing only the increasing order, right? If and this condition do not satisfy, then we will perform some operations, and we will try to keep our stack monolithic. Okay, So we are having currently 0 and 1, okay, into our stack, and then I is equal to 2, which is, we are going till n, okay. So 2 is equal to 2, yes, our, because we have traversed all the vector, and current height would be 0, okay. Now see, in the stack we have 0th and 1 index, but we have to calculate the area also, no? We have traversed all the vector, so that's why we are using this, okay. So current height, that is 0, is greater than st dot top, which is st dot top is equal to 4. So yes, this condition satisfied. So our current height would be st dot top, that is 4. We will pop out the value from the stack, that is 1. So we are here now, okay. This is on the third step. We will pop out 1, and then we have the height is equal to 4. Now we want the width. So what will be our width if the stack is empty? No, we are having 0 in the stack, right? So we will come here. Width would be I minus st dot top minus 1. I is currently 2, st dot top is currently 0, okay, and 1 minus 1. So 2 minus 1 would be 1 only. So width is 1. So max area would be max of max area, that is 0, comma height, that is 2, into width, that is 1. So 2. So max area will, sorry, 4. So max area will contain 4. Okay. So basically this one, 4 into 1. Okay. Now again, we will go through the loop, because our stack is still not empty, and st dot top, now we are here, now we have popped 1, so we are at 0. So st of 0 is 2. So 2 is greater than 0, current height is still 0, yes, condition satisfied. So our height will contain 2. We will pop the 0 value, so stack has become empty now. So in the width, if the stack is empty, what will we store? I. So I means 2. Okay. See, whenever the stack becomes empty, that means we are having the least value in the current height. Okay. So if it is the least value, that means it is containing among all the values of the stack or of the histogram. Okay. So basically 2 is here, it's the least, so it will be definitely be containing in this 4 also. Okay. That means we can multiply it. So basically 2 minus 0, so that is the size of the array. Okay. So that's why we are multiplying it. So the max of max area, which is 2, into height, that is 2, into width, that is 2 only. Okay. That is area size, that would be also 4. So max of 4 and 4 will be 4 only. Okay. Then we will push this 0, this 2 into stack, but it will return 0, because the height is can be 2, but the width will be 0 only. Okay. That's why. So the max variable will be 4 only. Okay. Hope you've got this particular concept. Okay. So in this way, let me maximize it. Okay. Okay, so in this way, this problem will work. Now, if I come to my first example, let's dry run this. So for the better understanding, right? Now we are at here. Our max area is 0. Our n is equal to 6, right? And we will traverse till 6. Okay. So our current height is 0. 0 is not equal to 6. So we will come to this while loop. Stack is empty. So we will not come here. We will simply put 0th index, which is containing 2, into the stack. Okay. Then we will come here. Our stack is not empty, and our height of st dot top, which is 1, which is 2. 2 is greater than 1, so condition satisfies. Okay. So we will enter into the loop. So our height would be st dot top, that is 2, and we will pop up this particular value, and our width would be this. If the stack is empty, see, stack was having 0, and we have popped out the 0, stack is empty only, and I is equal to 1 currently. Okay. So our width would be 1, and max area would be max of 0 into max of max area, that is 0, into height would be 1 into 2. Okay. So it would be 2 only. So our max area would be 2. Okay. Now we will come here, that is the first index. What it will do is, uh, okay, so what it will do, we are here in the 1. So this particular condition satisfies, that is our current height is I, that is 1 is not equal to n. Okay. The condition satisfies, and we will move into the stack. Okay. And our current height would be 1 only, so we will push 1 into the stack, and then we will come to this particular index, that is 5. So 1 is less than 5, So we will push this particular index also, that is 2 into the stack. We will push this third index also because 6 is greater than 5. Okay, and then when we come to this particular index that is having the value 2, so basically 2 is less than 6. Okay, so this condition satisfies, so we will enter into the while loop. When we move into the while loop, our height would be 2, right? And we will pop out this particular index value from there, and our width would be 1. So our max area would be max of max area into 1, that is width, into height, and height is 2, sorry 6, so it would be 6. Understood? And then again we will enter into the loop because 5 is there, so 5 into 2, 5 into 2, that is 2 width is there, so it would be 10, right? So max area would be 10. In this way uh, we will get the max area 10. Okay, and now this loop, we will not enter this loop because 2 is greater than 1. Okay, so the stack is valid now. We will come to 3 now, so still 3 is greater than 2, so we will insert 3 also into it. Okay, now what we will do is, it is equivalent to n, our array we have reached to the n side, so again we will calculate it, and the max would be, the first of all we will get the value 3, then 2, then 1. Okay, in this way still our max value would be 10 only. Hope you have understood this concept. Now we come to our original problem. See, here I had did nothing, but I have simply copy pasted the same code here, the largest rectangle area, right? So here I will do nothing, but I will create histograms, because see here we are given 2D matrix, right? So the first matrix would, the first histogram would be this one, that is 1 0 1 0 0. Why it would be? Because we are taken this vector. See, I'm traversing through this 2D array. Okay, and here if the matrix of ij is 1, which is in character value, right, then the heights of j would be incremented by 1. Initially the heights are 0, containing all the zeros. Okay, so height would be 1, so 1, then 0, then 1 0 0. Okay, in this way, and we will send this particular vector here, and we will get the height, which would be 1 only, because for this histogram the height would be 1 only, and the answer would be max of answer and 1, 0 and 1, which would be 1 only. Then we will come to the second row, so our new heights would be 2 0 2 1 1. Okay, this is our new histogram. I will send it here, and answer would be max of answer comma this particular, that is the largest area from this particular histogram, which would be 2, right? Sorry, 3. So this could be the one vector area, this could be the one area, and this, that is 1 1 1, that will be equivalent to 3. Okay, then I will send this particular histogram, so whose values will be 3 1 3 2 2, right? And the maximum area for this particular histogram would be 2 into 3, which is equivalent to 6, so I will return 6. Okay, and for the last index, that is this one, our histogram would be 4 0 0 3 and 0. Okay, and the maximum area for this would be 4 only, but already we have 6, so 6 is greater than 4, so we will return 4. Okay, so hope you have understood this particular problem. So basically we were given with the one problem, but basically we have solved two hard problems, right? Hope you have understood the concept. If you understood it, please make sure to like and subscribe to the channel. Thank you. See you in the next video. Till then, goodbye.